In this video, we'll introduce the improved bevel tools in SelfCAD. Bevel is the general term that includes both chamfer and fillet operations. We'll compare the traditional offset mode with the new solid, volume-based mode and demonstrate when each one is the better choice. Let's begin with a simple example. We'll start by creating a cylinder so we can demonstrate how the existing bevel tools work on clean geometry before introducing the new features and comparing the results. Suppose we want to round this edge. First, open the Advanced Selection settings and enable Loop Selection. Now select the entire edge loop. Loop selection works only on quad-based geometry, meaning faces with 4 edges. Since this cylinder consists entirely of quads, the entire loop can be selected without any issues. This gives us an ideal example because the geometry is perfectly clean. When working with clean quad topology, the traditional bevel tools usually produce excellent results. Let's open the Fillet tool. Set the intensity to 20 and the level to 6. The result is a smooth, rounded fillet with clean topology and evenly distributed quads. Now let's look at the bevel offset option. A value of 0.5, which is the default, produces a standard fillet. Setting the value to 0 creates a centered bevel. Changing it to -0.5 moves the bevel inward. All 3 settings produce clean, predictable results because the underlying geometry is simple and well-structured. Now let's compare this with the new solid mode. Switch to solid mode using the same settings, an intensity of 20 and a level of 6. Notice that the final result looks almost identical. However, you'll also notice that processing takes slightly longer. That's because offset mode works directly on the existing mesh topology, while solid mode rebuilds the result using a volume-based algorithm. For a simple model like this, both approaches produce nearly identical results. In fact, using solid mode here creates unnecessarily complex geometry without providing any noticeable advantage. This is exactly the type of model where the traditional offset mode is the recommended choice. Now let's look at an example where solid mode makes a significant difference. We'll create another primitive. Leave both the width and height at their default values. Next, merge the 2 objects using Ctrl+U, which performs a Boolean union. Notice what happened to the topology. The Boolean operation rebuilt the mesh, replacing the clean quad layout with a mixture of triangles and irregular polygons. This is perfectly normal after Boolean operations, but it also introduces our first challenge. Try using loop selection again. You'll receive the message, "Please select only quads for loop selection." Since the topology is no longer entirely quad-based, loop selection can no longer identify a continuous edge loop. This limitation isn't specific to the bevel tools. It's simply a characteristic of loop selection, which requires quad topology to function correctly. There are several ways to select the edges manually. One option is to select the entire object and then deselect the unnecessary edges. Another approach is to start with a polygon selection, switch to edge selection, and automatically convert the selected polygons into their corresponding edges. For this demonstration, we'll use the manual selection approach. Select these polygons. Now switch to edge selection. All of the surrounding edges are selected automatically. Next, deselect the edges we don't need until only the desired edge loop remains. You can also accomplish this using marquee selection. Dragging from left to right selects only elements that are completely enclosed within the selection box. Dragging from right to left selects everything the selection box touches. If you enable wireframe mode, also known as X-ray mode in many other 3D applications, you can even select geometry through the entire model.
Let's go to marquee selection. Then we can select it this way in wireframe mode, so it selects everything. You can see it selected everything over here. To deselect, you can go back to marquee selection and hold down the Control key to deselect.
Now we have the same edge loop selected, even though the topology is much more complex. Now that we have the edges selected, let's compare the two bevel methods on this more complex geometry. First, open the Fillet tool. Set the level to 6 and the intensity to 20. Immediately, you'll notice that the result isn't as clean as before. Because offset mode works directly on the existing mesh topology, it depends heavily on the quality of the original geometry. In this case, the Boolean operation created irregular polygons and triangles, leaving the mesh without enough evenly distributed faces to support a smooth fillet. As a result, the polygons begin to stretch, the surface becomes uneven, and in some areas, holes may even appear in the mesh. Notice that the fillet is no longer symmetrical. Instead of producing a smooth, uniform transition around the edge, the result varies depending on the surrounding topology. Let's increase the intensity to 40. You'll notice that SelfCAD limits the value to approximately 24.5. This safeguard prevents the operation from creating excessive self-intersections that would completely invalidate the mesh. You can enable advanced options, such as allow non-manifold geometry, but even then, the result is rarely usable for this type of model. The underlying topology simply isn't suitable for a geometry-based bevel. This is exactly the type of situation the new solid mode was designed to solve. Now switch to solid mode. Keep the intensity at 20 and the level at 6. Unlike offset mode, solid mode doesn't simply offset the existing polygons. Instead, it converts the model into a volume, performs the bevel operation on that volume, and then rebuilds the mesh from the result. Because it isn't constrained by the original topology, it produces a much cleaner and more consistent bevel. Notice the difference. The bevel is now smooth, symmetrical, and free from the stretching and distortion we saw earlier. Instead of trying to preserve problematic polygons, the mesh has been reconstructed into clean geometry. Let's look at another new feature introduced alongside solid mode: Enable Create Material. This option creates a separate material for the newly generated bevel surfaces. Although this option can also be useful with offset mode in the future, it's particularly helpful when working with solid mode because it allows the newly created surfaces to be selected instantly using material selection. Let's finalize the operation. Now switch to material selection. With a single click, we can select every face created by the bevel operation. This makes it much easier to perform additional editing later, whether you want to assign a different material, apply a color, or continue modeling only those newly created surfaces. If you open the material panel, you'll also notice that smooth shading has automatically been enabled. Smooth shading improves the appearance of curved surfaces by softening the lighting across adjacent polygons. Many professional CAD and modeling applications achieve visually smooth chamfers and fillets using this same technique. To better illustrate the effect, let's assign a different color to the newly created bevel surfaces. Notice how clean and consistent the transition looks around the entire model. This demonstrates one of the biggest advantages of the new volume-based workflow. Rather than relying on the existing mesh topology, solid mode rebuilds the geometry to produce a cleaner, more reliable result, even on models with complex or irregular topology. Now let's look at another example using the Chamfer tool. We'll continue working with this same model. Select the same group of edges. Open the Chamfer tool. Using the traditional offset mode, you'll notice that the chamfer initially appears to work. However, look closely at the result. Small gaps begin to appear in areas where the surrounding geometry is too dense or too irregular. Some faces collapse completely, while others become stretched or distorted. Although these holes can sometimes be repaired later using tools such as fill polygons, the resulting geometry is still far from ideal. Notice this section here. Instead of creating a perfectly flat chamfer, the surface becomes uneven because the surrounding polygons are pulling the geometry in different directions. This has been one of the biggest challenges when beveling complex meshes using traditional geometry-based methods. Now let's compare the same operation using solid mode. Switch to solid. Set the intensity to 25. Preview the result. Immediately, you'll notice the difference. The chamfer is clean, continuous, and symmetrical. Instead of producing stretched polygons or holes, the volume-based algorithm rebuilds the surrounding mesh to create a smooth, watertight result. Now switch to polygon selection and select one of the newly created chamfer faces. Notice how clean and perfectly flat the surface is. Let's inspect a few more faces individually. Every chamfer surface has been generated cleanly, with no stretched polygons, overlapping geometry, or unwanted holes. To make the new geometry easier to see, let's assign it a different color. As you can see, the chamfer is smooth, symmetrical, and consistent across the entire model. Now let's push the comparison even further. We'll increase the resolution of the model to create much smaller faces and a more challenging topology. Set the resolution to 5. This creates a much denser mesh with significantly smaller polygons. Select these edges once again. Now let's try applying a chamfer using the traditional offset mode. Preview the result. Notice that SelfCAD immediately limits the maximum intensity. Even if we try entering a value of 20, the maximum allowed value is only about 3.1. This limitation exists because offset mode works directly with the existing mesh. As the bevel grows larger, nearby polygons begin to intersect, making it impossible to continue without creating invalid geometry. Now let's switch to solid mode. Set the intensity to 10. Take a look at the preview. Unlike offset mode, solid mode isn't restricted by the original polygon layout. Instead of simply pushing the existing faces outward, it rebuilds the geometry entirely. Notice how the new chamfer extends smoothly from the original model while maintaining clean, continuous surfaces. The new faces are generated automatically, allowing the bevel to extend much farther than would be possible using a traditional geometry-based approach. This is one of the biggest advantages of volume-based modeling. Rather than being constrained by the size, shape, or distribution of the original polygons, the algorithm reconstructs the surrounding geometry to produce a clean, manifold result. Whether you're working with Boolean operations, scanned meshes, artistic models, imported CAD files, or highly detailed geometry, solid mode provides a much more reliable workflow whenever traditional bevel operations begin to fail. It's important to remember that offset mode hasn't been replaced. In fact, it remains the fastest and most efficient option for models with clean, quad-based topology. For simple geometry, offset mode produces excellent results while keeping the mesh lightweight. Solid mode is designed for those situations where complex topology would otherwise lead to stretched polygons, self-intersections, holes, or distorted bevels. Having both options gives you the flexibility to choose the workflow that best matches your model. Use offset mode for speed and clean topology. Use solid mode whenever you need the highest quality results on complex geometry. Together, they provide the best of both worlds. And that's an overview of the new solid, volume-based bevel, chamfer, and fillet tools in SelfCAD. We hope this feature helps you create cleaner models and makes working with complex geometry much easier. Give it a try on your own projects and let us know in the comments what you think. If you found this video helpful, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss future SelfCAD tutorials and feature updates. Thanks for watching, and we'll see you in the next video.